Okay, so I've been here about the same time as John. We started around the same time. Pretty much since I've been here, I've been working on ETLs at some level. Within the last few years, I've become it's become one of my ownership areas. So if you've been working on ETLs as part of your own work, it's possible you may have talked to me via Zoom or just on tickets. Hopefully you've had smooth sailing from our documentation. We have been updating our documentation, and some of that's been Steve, as well as Molly in this area, to try to provide better documentation so it's a little more clear how to develop these ETLs. And hopefully I can even provide a little more insight today on a few different scenarios. This isn't going to go over like every feature of ETLs. We're just going to go over these specific scenarios. It's hopefully, you know, some folks listening in have some exposure to ETLs. And just for the folks who don't, make sure my slides are working. So just a kind of a brief overview, if you've not seen ETLs, if you're tuning in just out of curiosity. So ETLs, really part of any data migration device is going to have some sort of ETL mechanism. Today, obviously, we're talking about it in the context of LabKey, and it's really just extracting data from, you know, one database, having the ability to transform that data if you need to reshape that data, rename stuff, if you want to provide some validation. That's kind of the transform layer, and then load that data into, in this case, loading that into your LabKey database. Okay, so the first scenario is incremental data migration of large data sets. So this is going to be kind of we're kind of jumping right to the main course here. This is kind of the majority of the time we're going to spend on this scenario, and then I'll touch on some other scenarios after that. But this is kind of one of the more common scenarios, and it requires a little bit more configuration to set up and kind of just to understand what's going on with the ETL framework. All right. So really what this scenario is you're generating data on one server, right? And maybe you're modifying that data, deleting data, or adding new data. And then in LabKey, you want to view that data, you want to aggregate that data, you want to create reports from that data, and so you want to basically sync your LabKey server with your whichever your kind of source server is. And that could be another LabKey server, or that could be some other database that LabKey is able to interface with. So some milestones of this is kind of an early milestone if you're doing a LabKey adoption from like a legacy system. This is one of the early milestones is bringing in your data from your kind of legacy system into LabKey so that you can view that data, start to develop reports, start to develop your own workflow for what you want to do with your data. You also might have collaborations that happen between labs or between centers. You see this sometimes where people are going to send some data and collaborate with, you know, between different labs, and so they'll ETL data back and forth to each other. And then you might also have cases where you're integrating LabKey into like a more complex workflow involving other software, and maybe that other software is producing data that you want to bring into LabKey so that you can do reporting and viewing on it. And so, so just to briefly talk about scheduling real quick, right? So what we're talking about is, you know, bringing these over on kind of a regular basis, right? Trying to keep these in sync, these two servers, right? Your source server and your destination server. So I can touch on scheduling real quick. And I've got some XML snippets here, and I'll go into bigger configurations of XML here shortly to show you kind of a full ETL definition. But an ETL can be scheduled, you know, on a bunch of different intervals, hours, days, months, years, and however many multiples of those you want. You can also schedule ETLs based on a cron expression, so you can get pretty creative with those. And that's you can Google cron expressions. They're pretty common expression format. And so here you can see there's a pretty specific cron expression there on when this ETL would run. Our ETL pipeline is single-threaded, and so when one ETL is running, another ETL cannot run, right? And so if you have long-running ETLs, you cannot run another ETL during that same time period. So that kind of leads us, I guess, to our challenge here with ETLs is performance, right? And so when you want your ETLs all to run at midnight or something, right? You don't want them still to be running the next day at noon. You want them to copy over that data and then have that available to folks whenever they get into their labs or whenever they get into their work environments. So kind of very simple, on a very simple level, ETLs do provide an option where you can essentially, every time you run an ETL, it will truncate the destination table. So delete all the rows out of there and reinsert everything from scratch. And this is a completely viable ETL configuration, and I'll show an example of that here shortly. It's going to be very completely accurate, right? Because every time you run it, you're just mirroring your source table onto your destination table. And so if you have data sets that are 10 rows, 100 rows, especially if you're not running the ETLs very often, this is a very viable solution for your ETL configuration. The problem with this is if you got ETLs that have thousands or millions of rows, right, this can get really costly in your database operations, right? Particularly if you have things like triggers on it, or you're doing some kind of transformations, like we talked about earlier with the T in ETL, or you have complex queries, you could get really long ETL execution times, and that's just the database operations take a long time to do, and there's going to be some some transformations and stuff happening in Java and in JavaScript. And additionally, LabKey Server has a lot of complexity in the database as far as a lot of the data types that LabKey supports. They allow you to do a lot of stuff dynamically, and so there's just because you're inserting into one table, you might be actually on the database side inserting into multiple tables. Excuse me, just to align metadata and align whatever configurations you've set for that particular data type. So the solution for this that the ETL provides is an incremental filter. And you can see here in the example, an incremental filter will provide a way to get to bring in only or to migrate only your new or updated data or your deleted data with every single ETL run. So what I'm showing here is just some new rows at the bottom and an updated row. And so the goal is to only bring in and only transfer those rows across and only update those rows in the database. So you're not just doing everything from scratch every single time your ETL runs. So we're going to talk about the extract. This is kind of the E part of ETL. And so mostly what we're talking about today is what's called a modified since filter strategy. And I'll show you the XML for this here briefly. And what this is doing essentially is, so your source, you have to have some sort of modified column. It doesn't have to be named modified. It can be named something else, but some sort of timestamp that gets updated every time a new row is entered or every time a row is updated. And like ETL has these, LabKey has these. They have the modified and modified by columns. So this is a requirement really for this type of filter. You have to have something that tells the ETL these rows are new rows or have been updated. And so what the ETL framework actually does is the first time you run an ETL, it will pull all that data over into LabKey. And when it pulls, after it's done pulling all that data over into LabKey, it will find the most recent or the highest value that's in this modified column. And it will store that value into the database. The next time the ETL runs, it will query your source for any rows that have a modified value that's more recent or greater than that stored value. So it would only, if the first run brought in all this data, the second run would only extract the rows here that are highlighted because they have a later date here that ran that was after after when the first ETL ran. And so that modified column is obviously a key part of this. And this is only handling updated and new rows. I'll show you deleted rows here in a moment, how we handle those. But first, we're going to jump to the L side, right? So how do we load this into LabKey? So ETLs have three different actual insert options. You can truncate, like we talked about initially, and that will delete everything from the destination table and reinsert whatever rows you've extracted. You have append, which will append all rows to the end of the data set that's already there in your destination. And then you have merge, and merge is probably what about 99% of the time you're going to be using this with an incremental filter. There might be use cases where you want it. I've not seen them. But what a merge is going to do, I have it described here, is going to, any new rows will get appended to the end. So rows 9 and 10 here, which were new rows, will get appended to the end of your destination data set. Updated rows, it will update everything except the primary key. And so that's how it knows when a row is a row that needs to be updated, or a row that's a new row, is it's going to look at the primary key and just to see if that row exists already. If it exists already, then it knows it's an update. And so it'll update that row that's in your destination. If it does not exist, then it just appends that row to the end. And I'm primary key, that's on the table. I'm using a very simplified example here. But primary key is the default column that it will actually merge on. But you can identify a different column, and sometimes you have to do that for some of our LabKey data types. That the primary key is like an LSID or something. Then if you're, if you're inserting into like a demographics data set, you would probably set your primary or your alternate key for the ETL to be the participant ID, right? Because you have one row per participant ID. And so you're guaranteed that's going to be a unique value in each row where it can identify which rows have been updated or which rows are new. So that's kind of the loading part. Still are not handling deletes yet, though. So deleted rows, as you can imagine, when we talked about the extracting rows, if you're trying to get all the rows that have been updated since the last run, anything that's been deleted out of there obviously is not going to return from that query, right? And so the server doesn't know anything about this row has been deleted. So that's where we actually require a second table. These are usually audit logs or audit tables. So I have kind of an example of one row up here at the top of an audit table. And then, so as you can see, what it would require for this deleted rows part of this incremental filter is it has that same modified by column here, and it will look that up the exact same way that it queries this down here. And this row ID has to, and it can be named, these can be named anything. I'll show you in the XML that you can name these anything. This has to match your primary key, or if you define an alternate key, it has to match that in your row that has actually been deleted from your source table. And so the ETL will just look at this. It'll say, okay, row 9 has been deleted. And on the destination side, now it will delete row with the primary key of 9. So that's kind of hopefully it gives you some understanding of what's going on there with the incremental filter as far as looking at the data. So I'm going to talk a little bit about like how do you set one of these up. Like it's a pretty big ask to just set one of these up from scratch and have it working all right away. So I'm going to go through kind of a step-by-step procedure on how we recommend you set up an ETL, especially one that you're going to try to get to have one of these incremental filters. So initially, you want to just set up a really simple ETL, right? And that'll just do the truncate, right? So that's going to bring in everything fresh every time. And this is going to give you an opportunity to look at all your data that's coming in, make sure that your columns are aligned. If you need to rename any columns or you're doing any transforms, it just makes sure that that data is getting copied over as you expect it to be copied over. So that's like real simple. Let's just get the copy part working. And if you're not familiar with the ETL XMLs, you can do this either in a file or through the UI. It is really the only way right now to configure ETLs is using an XML format like this. Okay, so the second step then is after you have configured your truncate ETL and you're sure that it's bringing over the data as you want, then switch that over to the merge option. And if you have an alternate key, add that to your ETL. And so what that'll do is that'll just verify that you're merging correctly on your key, right? And so update some rows in your source, run that ETL. It's still going to bring over everything from your source to your destination, but now it's going to try to merge those on that primary key. So now would be when you would, make sure that merge is working correctly. Make sure, if you update a row, they don't try to tack it on to the end, as a new row. Most of the time it would throw an error because there would have multiple values if it's a primary key, or you have some sort of unique constraint, it would probably violate some unique constraint. So this just gets that, verifies that that merge is working. And then it's time to add your incremental filter. And again, this is just for inserts or new rows and updated rows. And we're using the modified since filter strategy here. And like I said, that modified column, you can call it whatever you want. In this case, this is actually, they're calling this timestamp. I forgot to mention, this is actually a user's ETL XML. I took some identifying information out of it, but this is actually their ETL that is being used for one of the primary research centers. And so I'm kind of building that up to what their full ETL looks like. Okay, so at this point, then you can test out that your new rows and that your updated rows are the only rows that are being brought across via your ETL. You can look at this at the pipeline logs. You can look in your destination, and if you have modified and created timestamps, and make sure that those rows are only the rows that you're updating on the source side are the ones that are being ETL'd into your destination side. At this point, delete's still not working, so that's one of the final steps. In add the deleted rows source. You can see here as part of your filter strategy. There's a different query that we're using here. This group is actually using a view, and they're doing a little bit of transformations to align their columns with the columns on the LabKey side and a view on their external server. Like I said, the modified on the audit table can be named whatever. In this case, is the audit date time. And then these two columns align that primary key or the key you want to match on. In this case, it's the object ID with the column that's in your audit table that tells you which row actually got deleted. So now you can run this manually and verify that it is only bringing over that data. It should handle new rows, updated rows, deleted rows, and it should basically mirror that, your source, on your destination after every time you run this. And then the last thing to do is really just to add the schedule. And here, add the schedule every 60 minutes. You can add whatever schedule you want. And you can do it at a shorter increment at first to make sure that it's copying everything over, and then put it at whatever increment you want it to operate on a regular basis. And then you just leave that running, and it will keep those two, the source and the destination, in sync, at the frequency at which you are scheduled to run. So I left a few other things in here. There's a few things we haven't talked about in this ETL, but this is essentially the full ETL that is in service. We will actually talk about these column transforms next, but this is kind of like, this is what a kind of full built-out incremental filter ETL would look like. I mentioned there's one other filter strategy, which I just wanted to touch on real briefly. So I just got one slide on it. It's very similar to the modified since filter strategy. It just adds an additional table. And so this could be like if you have a batch of records or a run of records, or you might just have like a parent record of like, a clinic record or something like that. And what the ETL will do, and you can configure the ETL to look at this other table, it will look at the modified timestamp on this table, this kind of parent table, and determine which rows, which records need to be updated or have been inserted new based on this other table. And so here, saying run ID of 2 was updated on March 30th. And so in your actual table, your source table is going to go and just import everything over that has a run ID of 2. And it will try to match that primary key just like it did to merge in that. Everything else will be the same. It's just using this this other table as your indication of which one needs to be incrementally brought over. So I'm going to go ahead and take or see if there's any questions. So we cannot do a multi-column primary key for the ETL. So that if you're going to do that, keep clicking off you really need to define another alternate key. And so what you could do in that case on your source side, you could create a column that essentially concatenates those primary keys together into one column, essentially, and identify that, as your alternate key. That would have to be then, brought over to the destination side as well. But yeah, it doesn't, not most things, but majority of things in LabKey, I guess, maybe most things in LabKey really work best when you have a single primary key. So it's probably a good thing to, if you can have that single primary key, to have that anyway.
I'll have my own follow-up question here, Marty, on that.
Yeah, sure.
I have data sets, like study data sets. Those are, I think of those as having two primary keys. How would I ETL into that?
Yeah, trying to get stuff off my screen here. Okay. Yeah, so that's kind of what this case actually is showing here. So this one, they're inserting into a weight data set, study data set, and the primary key on those, I think, LSID, which is we're not going to probably have on the source, and I'm not sure. Maybe it's Steve. Maybe there might be another one. I'm not sure off the top of my head. But and so that's actually why they've identified another primary key here. And so, like, most data sets are going to have, at the very least, they're going to have a unique index on the participant ID and the date. So if you had to, you could have a kind of combination of that. I think there's like a participant sequence number you might be able to use. But if you can kind of identify your own primary key, like they did here, an object ID, and they're generating an object ID on the source side, and then having that on their destination side, so that they can kind of coordinate. And on the source side, that's what really aligns. So it gives the uniqueness to those rows, so that it can merge into this study data set.
Great, thanks.
So, yeah, that's a great question. Both are great questions. Any other questions before I move on to the next scenario? That was kind of our big scenario. And just because I think it's a little more probably common scenario. Okay, so this one, happens a little less frequently, but I've encountered it a few times recently, where you're trying to import data via an ETL into LabKey, and you have user data in columns that you want to align to a LabKey user. And so kind of this scenario is what I talked about. You might have performed by columns, modified by columns, contacts. You might have some sort of ownership of that data, or ownership of the procedure that produced that data. And then often has this historical information that's important to have for auditing reasons. And so you want to bring that all into LabKey, and you can bring it in just as a text field, and that's fine. That still gives you the full auditing, but sometimes it's nice to have it aligned as you start actually inserting data into LabKey, have that those columns aligned with the same user that's logged as a LabKey user. Sometimes what we're importing is from somebody who left the place a long time ago, so you might not ever have a LabKey account for that person, but we kind of handle that in a specific way for this particular use case. So before I get back to this, just to talk briefly about column transforms, because that's what we're going to use here. There are two types of column transforms. There's a kind of simple, just name mapping column transform, and that's what we're looking at right here. That is basically if your source has a column named order date, and your destination data type or whatever has a column named date, and this will just map those. So when you ETL in the data from order dates, will go into date. And you only need to put here the columns that don't match. Everything else that the names match will match up across your ETL. Okay, so the other type of column transforms are the Java column transforms. And that's where you can actually do some kind of transformations of your data as you bring it in via a Java class. And so as you can see, the XML on the bottom there is how you align that with a particular column. We do have an abstract class that you need to extend from if you're going to use this. It's called column transform. And then you can override do transform, and this will run for every single row of every column that is aligned to. And that return value is going to be what actually gets inserted into the result set, or the destination, whenever it gets returned from do transform. It does have other helper functions there that will allow you to get like access to the rest of the row, ETL information about that particular run. And so you can do quite a bit of transformation actually in these Java column transform classes. You can also do some validation there. You can, if you see something, we don't have like warnings or anything like that, it's kind of go or no go, but you can throw a column transform exception in this class. If you see something that doesn't meet your validation, that will stop the ETL, log that in the pipeline log, and that will make an extra layer of validation there. So back to our use case here, our scenario. We do have a Java column transform for user data. This is kind of an email prefix based transform. And so what I mean by that is, you know, to take off the @ domain or whatever. And there are certainly other ways of that on sources where people have, or where they've, this user data is saved in some other format. But this is kind of our example of how to do that, and you could possibly use it for your own ETLs. So what this column transform does is it actually, when it's pulling in data, so from the example here, right, it's pulling in actual email prefixes, right? It will go and it will try to look up that user or an email prefix, the email that has that prefix in as a LabKey user. If it finds that LabKey user, it'll just insert the user ID here instead of whatever the incoming row was, the text, which has that prefix in it. If a user is not found, it actually creates an inactive LabKey user just so you can have everything in that column is aligned with the same data type. LabKey user can't do anything, doesn't have access to anything, can't edit anything. It just gives them a user ID that you can enter in there, and then if down the road that user does come along, you can reactivate their account. You can add more data to their account and make that an active account after the fact. So what actually gets downloaded into the actual database is just the user ID, which I've got aligned here. Then you can go and just add foreign keys. Many of these have foreign keys by default, such as the modified by column in most cases. But add that foreign key to your LabKey users table, and then that will be, you know, just like any other foreign key in LabKey, that will be a clickable link where you can view that user's information, or you could actually add that to the grid itself if that was important part of the data that you're looking at. And so that is basically a LabKey user that's in there. We've done other variations of this, matching on first and last name across a couple columns, or you might just have a display name or something that it just has to be a unique name that's stored also in the LabKey users table, or unique field. That will essentially allow you to determine if there is a user that exists. And if it does, insert that user ID, or to create a new user and insert that new user ID. Yeah, so as with any kind of row level calculations, caching is kind of a vital thing. We do cache user IDs in this one, so you're not querying the database or querying our kind of database caches frequently, trying to just not ruin performance by adding this kind of transformation there. And so this is the exact same example I showed you earlier. This is that column transform. This is using the user column transform. If your use case is a little bit different, you can use this just as an example, create your own Java column transform, you know, extending that class, and yeah, you can insert it into your module or into your ETLs with a one-liner there. Just to kind of contrast and compare, you can essentially do the same thing with a trigger script. And it really has about all the same functionality that this would have in it. I think just kind of the comparisons, a JavaScript trigger, you don't have to compile that. You can just throw that on your server and it'll work. You know, it doesn't have to redeploy or anything like that. You write it up and you can put it directly on your production server if you wanted to. Whereas a Java class, such as these Java class transforms, require being compiled and deployed to your server. However, triggers, you have to define triggers for every table that you want that trigger to act on. And triggers can be a little challenging to debug. They're, generally they're written in JavaScript, on server-side JavaScript, and so you can't really put breakpoints in there. You have to kind of do console log messages, so a little challenging. Whereas a Java column transform, once you've created your Java class, it's kind of a one-liner in the ETL, and you can add it to as many columns as you want. So maybe a little bit easier to add. And I would say it's also a little more apparent if you're looking at the ETL, what kind of transformations are going on, versus a trigger script is a little bit more hidden and not always apparent that you have some sort of transformation going on. And there are just some LabKey data types that don't yet support triggers. And so this would be a better case that would match that case. Any questions on this stuff? Okay. So you can ETL. So we have different ways to bring in data from files. You can ETL from files. We also have file watchers. Let me look real quick here. Sorry. You can ETL 2 files, and it will actually create a file for you every time. Sorry, this is one of the questions that came up about ETLing from a file. Generally, we have file watcher that'll come in, and you can set those up to watch a specific directory and pull in that data. It pulls it in via the pipeline. I'm just trying to see if we have the configuration actually set up to import that. Yeah, so we have load ETL. Yep, and so you can ETL to a file, and so that could be the target or the destination of your query. Yeah, file base name, file extension, all for file targets. Yeah, actually, I think right now we don't. I'm not sure we actually have that set up to import with the ETL configuration to import from a file. You can do that via file watcher. You can set up pipeline jobs to do that. The ETL can be set up to transport to a file. But it looks like we don't actually have the destination type yet as a file. And could LabKey auto-generate an ETL per table, perhaps as a template for truncate option? We don't have that capability right now. It would not be too hard to write a script or something like that that could do that. And I was going to do a poll, and I didn't get it done in time to see what some of the features that people would be interested in. So I'd be happy to, if folks have features like that, happy to hear either via the chat here or via support tickets or other things. Ways, folks are always running into things that they wish that we supported with our ETL framework. So please let us know when there are feature requests, and we have a whole process for kind of evaluating those, and the more people who are requesting those features, the more chance that we'll want to make that work for you. So hopefully I kind of answered your question on those 2 questions. I don't see any other questions at the moment, so I'll go ahead and go on to the last scenario. So this is migrating data between 2 LabKey servers via an ETL. And so the difference here is, I want to make sure I'm clear about the difference here. So the difference here is what I've kind of been talking about, and what the previous example was, right, is we are using an external schema to an external database, and we're talking directly to a SQL server or to Postgres or to Oracle, some other server, right? And that's kind of this example that we've been talking about here. This scenario is actually when your source is another LabKey server, right? And so you're trying to move just data between one LabKey server to another LabKey server. And again, some of the pretty similar examples here. This could be either collaborations between labs that both have LabKey servers, Sometimes we've seen aggregation of data coming in kind of some large build-outs from clinical data coming into kind of LabKey node servers, which they kind of groom that data and then use a LabKey to LabKey ETL to kind of a central server to actually perform or have that available for research. And then there are some cases where they kind of do the opposite of that, where they have kind of a central server, such as like a primate EHR or something, and then you might have other labs with their own LabKey servers who want to get some of that EHR data ETL'd into their server. So trying to just contrast the difference here, what I was just talking about. So this is what I was just talking about from the previous example, right? So this is a LabKey ETL that is pulling data from, say, Postgres on another server. And it's using a JDBC interface to do that. And that's set up through your labkey.xml file and an external schema. And it is querying this external Postgres database and getting a result set back all via JDBC and an external schema. And so that's kind of like the typical ETL. Now, if that source is a LabKey source, we do not want to do that same kind of ETL, and here's why. So I don't know if you ever looked at, if anybody's ever looked at a LabKey database, they probably can tell pretty quickly why that won't work. LabKey provides a lot of scoping by container, allowing you to make the same named data sets across containers, and has to handle permissions across containers. So there's a lot of unique names that are actually in the underlying database. You don't see this in the UI, but what's in the underlying database is actually sometimes doesn't match very closely with what you see in the UI. It's also very complex data structures. We rely on tables kind of dynamically, and so there's just some complex data structures, and then we have associations between runs and assays and participants and studies, and so it's very complex if you actually are trying to find your data in an ETL or in a LabKey database. And so we generally, we just really don't support that. And really, we do schema changes all the time to try to improve performance or improve functionality. And so we could just, that might be pulling the rug out from under you if you were ETLing directly from the LabKey database. And I'm talking about like the Postgres database or the SQL Server database that LabKey is actually sitting on. So what we do for ETL is we actually do what's called a remote server. And so this is, you set this up through your UI, and you just need the address of the server and a login. And what that's actually going to do, you'll have the exact same format to your ETL. This would be just like this configuration, and all these still apply, all these settings. But instead of using the JDBC interface, it's actually using our remote API, and it's really just doing query.selectRows with all those filters applied from like the incremental filter or the run filter. And so it's really just going to be going over HTTP interface and request and response and getting data from your external server that way. If you are ETLing on the same server, just from LabKey to LabKey, you don't need to do this because you're already on the same database. And I'll kind of get into that in a minute. You're already using the same user schema. So we kind of talked about why you don't want to do it directly from the database. Some of the benefits actually of doing it via the remote API is that is a very simplified kind of layered view of LabKey. But here on the bottom you have your database, which is your Postgres SQL Server. On top of that, in the Java code, you kind of have the DB schema, which handles transactions, connections. It's kind of your translation layer. And then on top of that, you have the user schema, and that's where a lot of the utility of LabKey comes in. That's where like all these relationships are maintained, the kind of foreign keys and virtual foreign keys, and all the metadata gets applied there that might actually not be stored, might be stored in a completely different table, and you can change it, and it will apply that at the user schema level. And so by using the remote API, you're basically everything your LabKey is querying, your ETL is querying, is exactly how you see it in the UI, right? The API and the UI both use the user schema in the exact same way. And so by using a remote server and the remote API, you don't have to know anything about the database, or the actual lower level database. You just set your source to whatever you want it to be, and then you can ETL data that way. If you're ETLing on the same server, then you are already using this user schema, the same user schema. So you can do just a regular ETL, but it will know that you are ETLing from this user schema. You will not do a remote server if you are on the same server. So here's kind of the only difference really in a remote server. So you have a different type of transform here. This is a remote query transform step. And then your source is going to look just a little bit different. It's going to be a remote source, and I'll show you the UI to create that in a moment here. And then in this case, we're ETLing it from the study weight dataset on this other server into the study weight dataset on your destination server. Everything else will still apply. It's just a little bit different how you are querying a LabKey server. Setting up the remote server, pretty simple. It's if you go to the Schema browser, you have a button here to click, and that'll take you to a UI that looks like the bottom part. And it's just all you need is the URL. You do have to give it a folder path, which you're going to give it access to. It is done with a single logon. And so every time that ETL is accessing that server, it is using this logon. And so that is somewhat of a limitation, and that's why we kind of restrict, for security reasons, how much you can do with a remote server. You can't write queries against it. You can't view the data directly. It's really only used for ETLs, so you're not giving access to people who don't have access. And ETLs are all admin level ETLs. But since you can't write queries against it, you have a little bit fewer options for transforming data. You can't write a complex query on your destination side like you could with an external schema, which is a little bit different than the remote server, right? So a little bit fewer options for transforming that data. Okay, I think that's about all I got. Sorry, I think I took up a majority of the time. How are we doing on questions? It looks like I don't see any new questions. Hey, folks have any questions or thoughts or even feature requests or anything they want to ask about? I don't think I have too much else. Since we have a few minutes left, just to give people as much information as possible. We have a couple options here I didn't really highlight. Oops. Bulk load and batch size are two additional ETL options that you can put on a destination. Bulk load, essentially, really all it does is it cuts down on the amount of auditing you're doing. So if you are bringing in 1 million rows, you're not going to fill up your audit logs with 1 million rows of audits. It'll kind of give you a summary view of in your audit logs of how many rows were imported or inserted. Batch size, this is essentially limiting the transaction size of your ETL. And so this is actually useful to speed up for performance reasons. Sometimes if you have a lot of operations going on and those transactions are getting really large, it can take a long time to start. Those inserts can get really slow. So sometimes it's good to set a batch size to kind of limit the amount or the size of your transactions. Okay, excellent. I'm glad that was useful.
Great. Thank you so much, Marty.
Yeah.